Hello everyone and welcome to a new episode of All Things IDA. In today's episode, I'm going to talk about headless programming for IDA. Now, as you know, in IDA 9.0, IDA supports officially headless programming via IDA as a library. So like this, you can produce standalone binaries or standalone scripts that don't require the IDA UI to be executed. Additionally, I'm going to talk about idahost, the plugin I wrote that also allows you to do headless programming for IDA before 9.0, so any older version of IDA as well. I've been sleeping on that project for a while until 9.0 is out. Alright, and finally, as well, I'm gonna cover again headless programming using IDAPython. With that, let's get started. Now, historically, before IDA 9.0, the way to run scripts in a headless way, I'm saying headless, but it's not very much headless, is to pass the -s switch to IDA of your choice. And normally people were using IDA text UI, so ida.t.exe. You could equally pass ida.g, ida.q, or ida.exe. But the executable of choice back then was IDA text UI and -s switch. -s switch allows us to start IDA and execute the script. Now, inside the script, we can do most of the logic and also at the end quit IDA. And this gives us the appearance of headless programming. So there was an old blog post from 2010 talking about a utility called idascript where it was wrapping ida.g as well. ida.g was an old executable when IDA was using Borland C++ builder before IDA-Qt. And so the idascript utility was wrapping around the IDA executable to pass the -s and the script. And so this used to be one way to do it, of course. Now this project as well, you can find the source code here, pretty old, not maintained, but for historic reasons, you can take a look at it. The idascript project, for example, illustrates how we can have a standalone script and do, for example, function enumeration and so on. So this is idascript, which is a wrapper for the command line argument -s. Now let's skip ahead to IDA 9.0 and I'll finish with IDA 8.4 and before how we can use headless programming. So for 9.0, let's go to the IDA installation folder and go to IDA. We will see idalib. So idalib here is where we have the IDA as library. In the README file, it does talk about Python and C++. So I'm gonna talk about the C++. So all we have to do really for the C++ version, let's go to IDA SDK. So now I have IDA SDK 9.0. There will be inside it, we'll see here, of idalib, we have a standalone example. The key really is to link against idalib. So I'll show you here in the libs. And this is what we need to link with. And this will have idalib.dll as a static dependency. So that will let us use this. And that's it. Then we can work with it. So since I don't use the make files in the SDK for Windows, so I use ida-cmake, and I just updated ida-cmake to support IDA as a library. And we're gonna use that as a quick demo. So all I had to do is simply clone ida-cmake to the SDK, the usual ida-cmake installation. That's how we do it. We just simply clone it and just go to the folder, go to idalib and grab the example. So here I have idalib. I took a copy of that example from ida-cmake and we can tweak it and so on. Let's take a look real quick what we're dealing with here. So what do we want in order to achieve that? The first thing is a makefile, and the makefile here, all it has to do is simply let it find ida-sdk.cmake. And once we do that, we can formulate our make script like the usual manner. So add executable, your main source file or source files, you can add as much. But we are linking against idalib idalib.lib and ida.lib, so the IDA SDK itself and idalib. We still have two dependencies. And again, like plugins, where we have at least the ida.dll as a dependency. So ida.dll is the SDK. This is backed by ida.lib. And the headless part is idalib.dll. That's why we need two lib files in our project. So if I go back here, so just the target link library, your project's name or executable name, and two libraries. And the include directory is just the path to the SDK. So these are stuff given to us by ida-cmake. So once you install ida-cmake, if you are building your own CMake script, once you include ida-sdk.cmake, you will get all those variables you can use in your freestyle CMake file. So that's it. Let's take a look at main. Main is simple program, nothing special. What we need is we need to point to idalib.hpp. This is important. This will give us the bootstrapping functions. So things like init library, open database, and I'll show you a bunch of other functionality from the IDA SDK. So here, if I go to include idalib, so we have a bunch of stuff we can use. We need to call init library. And as you notice, it takes arg count and argv. This is almost like passing the arguments. So we could have passed -z to enable debug output and so on. We can pass 0, it's fine. And then we have open database, close database, make signature, enable console messages, set screen EA. Maybe in the future Hexrays will add more stuff, but what we need at the minimum from idalib is included, call init library, make sure we check the return value, and call open database. After that point, we can use the SDK like before, as if we're writing a plugin. So here, for example, I include pro.h and funcs.h. So here I'm doing it func quantity and getting all the names. So this is a minimal C++ program that uses idalib. We can build it as a standalone program. So the first step is cmake -b build folder and make sure we're specifying x64 target because we are only dealing with 64-bit binaries. That's it. So by doing that, it will create a build folder, and inside the build folder, it will have the project. If we want to use Visual Studio, we can, or we can build from command line. So let's just switch to release with debug info, set this as startup project. Now, one important thing. First, let's build from Visual Studio. Let's just hit build. And I'll explain to you an important requirement. So the binary went here. Let's go to the binary here, and this is the binary. If we look at the import directory, so we can see it has dependency on idalib.dll and the SDK functions we used. And if we're not statically linking, it will have C runtime dependencies. But you can see it needs to find ida.dll and idalib.dll. What it means is if I just run my idalib like that, I will get a loader error, of course, because it can't find those dependencies. So it is important to have ida, the version of ida we want, to be in the path. So I can do this in multiple ways. So I'm gonna just do it from Visual Studio for now, so that when I'm debugging, I have that path environment variable adjusted. So here I can edit the path. I'm gonna point to, for example, my IDA installation. So I'm gonna say the environment is this. So now when we run the process, it should know where to find ida.dll and idalib.dll. And that's it. So I simply adjusted the path to point to IDA so that it will pick up those dependencies. That's all I have to do. And since this test program, I have it pass the database, I'm gonna give it a test database to work with. So I prepared one here. And that's it. Now, by doing this, when I run it, it will be satisfied with respect to finding the DLL dependencies, and it will have the command line to work with. So mandatory init library, open database, and then we're ready to work with the SDK normally. And finally, we can close the database, close and save, or close and discard. So now I can put a breakpoint, for example, and hit F5. So now let's take a look at the console window. This is the console window here. You can see the moment the idalib.dll has been loaded, it prints itself as a message. And then init library executed, so I'm single stepping. Open database, succeeded, 0. And at this point now, I'm working with the SDK. So get func quantity, get enfunc, get func name. So let's just let it run. I'm gonna hit F5. And here we have it, a simple C++ program. And all it did is simply print the message, the functions. We can do everything we can do in the SDK minus the UI functionality, but you can use any equivalent. So you can use get string, you can use get ch, you can have your own input library framework, whatever. This is meant for IDA to be used as a library, so you embed it in your full program. So as simple as that, we have a standalone program. So here my idalib, we can run it standalone if we wish. We can just simply repeat the same, just set the path, and now we're good. Now we can say my idalib and give it the database, for example. And here it is, very simple. Now let's talk about IDA as library for Python in IDA 9.0. So if you go to the IDA installation folder, idalib, Python, that's where we have the stuff we need. So here in this folder, I have the setup script and an activation script. Everything is explained in the README file, what we need to do and so on. But in a short form, all we have to do is run Python and specify the setup script and say install. Now I have it already installed. It's gonna install an idapro module. And so idapro module is already there anyway. I have it running and so on. So I have it already installed. And the second step is, as per the README, we have to run the activate. Now activate takes an optional argument to tell it which IDA version we want to use. If you have multiple copies of IDA 9, then you can point to the copy you want to work with. So after we activate it with no arguments, it will pick up the parent folder as default, unless I specified -d. And that's it. After I activated, all I have to do is simply import idapro and use it. So the first thing you need to do is import idapro and then the modules you want to use. And you don't have to call init library. Why? Because it is already called for you in the sources of idapro. So if we look at idalib, Python, idapro, if we look at init.py, this is the package here. This is the init script for the package idapro, and here we can see in the main scope it is doing init library for you. So that's why we don't have to do it. And it is exposing all the other stuff we need from the native code, close database, open database. So that's it. Simply import idapro. It will init IDA automatically, and then all you have to do is open the database of your choice, use the regular IDAPython APIs, and through idapro you close the database as well, and you're done. So if we try to execute that, we don't have to specify IDA in the path. That's why the activation script works the way it does. It will hard code this, and the Python module will dynamically load the dependencies. So by the time you start using some stuff, already the proper IDA has been picked up. We will see it here as well. We should see, for example, at least in the Windows code here, it's gonna set default DLL directories and so on. These are the stuff that it picked up from the activation script. It will adjust the search path so that our Python host knows where to find the dependencies, idalib and ida.dll. So let's run it here. All I have to do is say Python and the script, and this script hard codes the test database and so on. We should see the same output, like the list of the functions. And before I conclude, I would like to remind you as well, you can also debug. So for example, here I have the script open. It's a regular module. We don't need to be hosted inside IDA anymore. We can have here VS Code hosted, and we can use the debugger. So I can put a breakpoint here, hit F5, select debug the current file, and as long as Visual Studio is using the same interpreter where we have the idapro module installed. It will pick up idapro module and it will work equally, so we didn't have any complaints here. Now we can just open database and you can see the output here and let it run and so on. Now I'm going to talk about headless programming for IDA and hosting IDA in your own process, whether it's a console app, graphical user interface app, the same way as idalib, but for IDA 8.4 and below. And the way I achieve that is via a hack that saves me time and also makes me avoid reverse engineering IDA and breaking the EULA, and also not using any undocumented APIs. But since I worked at Hexrace, I already have an idea how to build another IDA host. And I will discuss how I built another implementation without breaking the EULA or using any undocumented stuff. So I'm going to start with some background about writing a host for IDA or mimicking the IDA as library before 9.0. So the idea, and again I repeat, I know this because I looked at the IDA sources back in the days. So the idea is to use a function called init-kernel. Now init-kernel is not exposed in the SDK. So I'm looking at 8.4 since now we're done with 9.0. And init-kernel is not exposed, but it's a way to also pass the default call UI callback. That will help it have the UI backing to display messages. Also, it will let IDA work with the debugger since the debugger is hosted in the UI and so on. So the construction of an IDA host from scratch relies on having a standalone application, for example, which will leverage ida-DLL. So it has to use the IDA SDK. So here ida-DLL from 8.4, that's the kernel. But what we're writing is a host and another IDA replacement, so to say, which eventually will be your host to do anything, a specific application using the SDK without the full UI. So a standalone application would have to call init kernel, pass whatever arguments, including a call UI callback. The call UI will be responsible to answer to a large number of callbacks, but at the minimum, you have to at least answer maybe 40 or 70 callback messages, and you should be good to go to have a minimal IDA host. After that, you call init database and terminate database. But to write a better IDA host that supports debugging and the variety of stuff, you really have to implement correctly a bunch of UI notification events. And there will be other conditions as well. But this is gonna be using undocumented stuff in IDA. So I don't want to do that. So I'm gonna show you another, I would say, a hack that is clean enough and comprehensive enough and was very fast for me to implement. And let's look at the idahost source code for that. So then first let's clone idahost. I'm gonna start from scratch, show you how to set it up. So here, let's clone it here. idahost requires IDA SDK 8.4 and below. So right now I set my system to point to IDA SDK 9. So let me tell it to use IDA SDK 8.4. So let's just, in this prompt here, let's change the title and say IDA. This is setting it for ida-cmake. So I'm gonna point here, and also it's very important. Now ida-cmake, I have completely got rid of 8.x from ida-cmake and moved it to another branch. So now if you go to ida-cmake, it will not support anything before IDA 9, but you can always use the 8.x branch. So once you use the 8.x, you're fine. So what I did here in idapro 8.4 SDK, the ida-cmake here is a copy of the compatible ida-cmake. So I cloned ida-cmake and simply switched to 8.x branch, and I'm good to go. So now that IDA SDK 8.4 is properly set up, I can simply run the same cmake initialization. So I'm gonna say that It's 64-bit. So idahost, I made it just for 64-bit, no ida.exe. So this should be good enough for us to generate the solutions. This is the first step. Good to go. And now I can go to the project here, the test project, and look at it. So just quickly, if I jump to the host example, just show you how it works or how it will look like. So mind you, I have designed this long before 9.0. I had no prior knowledge what the interface would be in IDA's library. So, but that's how I imagined it. So I have an IDA host, and inside IDA host, you have a bunch of stuff you can use. We will talk about them. So you include IDA host, then you have an options. Here in the options, I let you specify IDA directory, IDA bin, input file, log file, and the debug flags. This is the wrapper behind the -z switch. So for example, if I wanted to debug plugins, I would specify here in the options and so on. So idahost init, give it an option structure, and at the minimum, I'm giving it the database. Once idahost is initialized, now you are inside the regular programming, but of course headless. Now, how does that work? So let's quickly take a look at behind the scenes and the approach I took here. So real quick, I knew that I can't use init kernel, and I don't want to implement 70 more or less callbacks. And I know as well I'm not gonna implement most of the debugger callbacks and so on. So what is better than simply leveraging most of the logic from ida-t? So ida-t itself is around 1.6 megabytes, let's say, and it has all of the logic, all the call UI, it calls init kernel, it does everything. And if we look at ida9, actually, idalib.dll, it's almost the same size. This gives me a confirmation that they took most likely the ida text UI, cleaned it up, kept most of the logic, and just turned it into a DLL. I could be wrong, but this is what I believe happened. So let's take a look at the approach here. So the approach I took is I wrote a reflective loader that will let me run ida-t64. ida-t64, let's see where it is. So here I have hard-coded it here by default. And what I do is I simply run it reflectively, let it initialize, and once it's initialized, ida-t, when it's initialized, I take control back. So we're gonna formulate the command line. I also hook a bunch of APIs just to fool it, so it thinks it gets what it needs. And then I simply do the reflective loading here. Very simple. Reflective loader doesn't support everything, so no TLS callbacks, just very minimal mapping and relocation and import resolution. Very, very basic, nothing much. And after IDA loads reflectively, IDA console, IDA TEXE loads reflectively, IDA will issue an idle event, and that's where a secondary helper plugin was developed. So if I go into the idahost, there is a companion plugin you have to deploy for idahost to work. So in the plugin here, I made that plugin talk to the host itself. So since IDA is gonna be hosted in your standalone program, even plugins will be in your process space. So here I intercept a bunch of UI messages. For example, if you issue an MSG function here, I intercept it and convert it, for example, to printf, and so on and so on. But the most important thing I do with the additional companion plugin for idahost to work is wait for the UI is ready. The moment the UI is ready, I switch back to your main process. So this is how it works. We start here, we specify the options, in particular which IDA to run, I pick up ida-t64 from the folder or the path and then execute it reflectively. The moment the UI is ready, I know and I issue a return to host. Return to host uses a clever trick via fibers to switch back to the execution point after the reflective loader. So I'm using fibers to switch context in the same thread. That once I switch, so once it says here, I make sure I create the fiber and so on, and I switch to ida.exe fully. So now, not only I reflectively loaded ida, I also let it get the execution. So I let it run, but then the plugin will let me switch back to the host. So like this, I gave ida and all its dependencies a chance to execute and do whatever it wants. When the UI is ready, I assumed it is safe to simply hijack the context back to the host. So after this, let ida-t execute, ida-t executes, sends a ready event, the companion plugin picks it up. Once it picks it up, it will switch back to this point onwards, and I'm back here. If I say message will go to the IDA SDK, which means ida-dll. Since ida-dll has been properly loaded and initialized reflectively by ida-t64, it will work. And so calling getFunc, it will work, and all those will work accordingly. Now, as well, there is one nice feature I implemented. I find very useful, which I don't see yet in IDA as library. So here what I can do as well, especially for troubleshooting, I can simply say idahost.interact. You can hide this behind a condition of your choice when you're debugging. We will test the code and you'll see how the interact works. Let me build the companion plugin. First, a good practice to use idahost and IDA SDK 8.4 and below. I want you to take a copy of your IDA binaries. So we go to the IDA 8.4 installation. And we copy the whole folder to a new folder called idahost. And so now I have a idahost folder. That's it. It's the binary folder copy of an installation of IDA. That will be the support for an idahost program. And also we'll make sure that we build the companion plugin. So let me build the companion plugin as well. So the companion plugin is inside idahost plugin. So idahost plugin, let's go to that folder. I'm gonna tell ida-cmake as well, not only the 8.4 SDK path, I'm gonna also tell it the override the bin folder and have it work with the idahost. So like this, my companion plugin gets deployed automatically to the idahost plugin folder. So now here, this is the regular IDA plugin. So if I'm using ida-cmake, all I have to do is simply initialize it. And once I do that, I will build it. It will be deployed in idahost because that's another requirement. And we can build the release one, not the debug one. And here we see the plugin has been deployed in the host directory. That's all I need for idahost to work. Same story like IDA's library. We have to tell it where is the host. So we'll have to change the path and so on. Let's take the idahost path and use it in Visual Studio so that it's picked up correctly the static dependencies. Alright, this is my standalone program. As you can see, I have to include idahost and the SDK, and this program also links with the SDK. So it will have a static dependency on ida.dll. That's why it's important to have the path environment variable correctly pointing to the path containing ida.dll. And same story, we're gonna go to the environment and specify that. This is where you should be looking for ida.dll. Now, IDA 8.4 or below doesn't have idalib.dll. So we'll see when we build it, we'll look at the binary and we'll look at the imports. So here I have the host, that's the host. We can go here, look at the import directory, and the only dependency is like a plugin. It's just the ida64 DLL. If I wanted to run this from the command prompt, I just have to make sure it can find ida64.dll. Now, this should be good to go. I hard-coded database. I'm calling idahost and so on. We can put a breakpoint here before we run it. Let me make sure I specify a compatible database. And now let's hit F5 and this should work accordingly. Let's see here. Okay, let's have it initialize. As you noticed, ida-text.ui showed temporarily, it's fine, but the idahost behind the scene hides everything. So if I now run it, you will not notice that again. That's just because the plugin UI ready message was not delivered yet, so we didn't have a chance to hide the console, switch screens, and so on and so on. But after the init, you should no longer see ida text unless we do interact, for example. We'll see. Anyway, so let's say message, for example. You can see here message is hello world, get function quantity, get function name, display stuff, and so on. Let me put a breakpoint at interact and wait a bit. So now it's emitting all the functions, for example, in this program. And suppose in your headless programming, you found a bug that's very hard to spot and you really need to drop into IDA and figure it out graphically and resume your headless programming. And so that's where interact takes place. As well, I use the same trick using fibers to switch back to the context I hijacked initially, to that switch context from the UI ready callback. I'm switching back to it, letting IDA resume normally and so on. So let's test the interact and see what happens. So the moment we say interact, I'm gonna swap the screen back to ida text, remember this screen, and then when we exit the interactive mode, we're gonna restore back this screen. So let's hit F5 here, let interact take place. This is interact. Now suddenly I'm in ida text and I can do whatever I want. If my code here changed the database, whatever state it's at, right now it's suspended, we can come back and continue. So here, I see there's a problem. I can invoke the UI, invoke the decompiler, etc. So if I want, whatever I want to do to finish my investigative work, then in the companion plugin, I have one functionality. I called it exit interactive mode. Come back here and let it just clean up and terminate. I'm not gonna maintain this project. I would say it is a proof of concept level. So that's it for today. We covered in details how to use headless programming for IDA, in particular idalib for C++ using ida-cmake, how to use idapro module for IDAPython programming, and finally how to use idahost as a way to have the same functionality as ida-lib but for IDA 8.4 and below. Thank you, and I'll see you next time.